5, Lesson 2, Proportions. Down here, looking at 7RP2, currently we're really going to focus in on this recognize and represent proportional relationships. And we're going to be working our way towards identifying the concept of proportionality. That will come later as we talk about today. We're looking at mostly just that phrase, proportional relationships, and recognizing them. So to do that, let's talk about proportion. A proportion is an equation stating that two ratios are equal. This word ratio means a fraction. It involves two numbers. Everybody say two. Did you say two? A ratio has two numbers, so it's separated by division, aka a fraction. So a proportion are two equal ratios or two equal fractions, kind of like 4/8, and that simplifies down to, that's equivalent to 1/2. These are a proportion because it's an equation saying that two ratios, two fractions, are equal. The next one is much the same. We're just adding that AL there at the end, that suffix. This says proportional, or when two quantities form a proportion. Thus, if you wanted to talk about 4/8 and 1/2 in and of themselves, they, when you compare them, we would say they are proportional because they make a proportion. Again, the proportion is just up here, stating that two ratios, two fractions are equal. We're going to look at that a lot, but we're going to talk about this phrase here, cross product. The definition is, in a proportion, the product of the numerator and the denominator from opposite sides are of the equal signs. Now that cross products are equal, that is not, note here, that is not a smiley face, that is equal in shorthand there. But that's a lot. So let's show you what we mean by that visually. I've run out of room here on the bottom, so off to the side, I'm going to write it on in. Could you write with me an algebraic example, meaning an example with letters? I know not our favorite, but I want us to get more custom and used to that as we get closer to pre-algebra and algebra. So if you could please put down A over B. So that's any number A over some number B equals C over D. So basically, it's saying there's four different numbers. And we're going to do this cross product. Well, there's a couple of phrases here. First off, one is cross. So when we say cross, everybody say cross. Did you say cross? Cross means going diagonal. So we're going to go across, down here, and we'll ricochet off. Whether you want to play ping ball or ping pong, bing, bing, ding, we're going to ricochet off. And then this word product is our other important word. Product means to multiply. Everybody say multiply. Did you say it? So we're going to take that and do A times D, and that cross product is equal to the other cross product, where we take the other diagonal, the cross, and go C times B, or I'll write it out B times C, so it's alphabetical. Yay, cross products! The letters don't exactly mean much, but let us look at a numeric example. Let us look at an example that we're going to see, not with letters, but with numbers. So we'll go to the next slide. Proportional or non-proportional? That's what they're going to ask. Do these ratios form a proportion? Now, there's a couple different ways we can do that. One, we can just look at it and say, do they make equivalent ratios? Meaning, can you simplify them to the same thing? So if I took and divided this by, not 5, sorry, that's the answer. Divided by 2. I get 5, and if I divide this by 2, then I get 9. Okay? So then let's see here. Can anything go into both 45 and 81? Well, eventually we can get down to 9 divided by 9. See, 45 divided by 5. Sorry, 45 divided by 9 is 5. 81 divided by 9. So right here, that's what we're going to ask ourselves. Did we get to an equivalent ratio? Yeah, we did. They have the same fraction. So yes, then they are proportional. Ran out of room on that. I apologize, guys. But there's another way we could go about doing that. And when we look at that, that's where we could use what was called the cross product. So let me create a little bit of space here then for us, as I'm going to clean this up here just a little bit. The cross product is where we're going to do just that. We're going to do the cross product. Cross meaning diagonal, and product means to multiply. So when we hear the word product, say product. The word product means to multiply. So go and draw a line crossed diagonally from the 10 to the 81, ricochet off, and please write down the numbers that you touched. 10 times 81. Put down an equal sign, but don't tell me what that equals. We must do the other cross product. So pick up your pencil. Everybody pick up your pencil. Put it here on 45. And then go again cross, go diagonal, dink, dink, ricochet off, and write down the numbers that you touched. Once you've done that for both of them, then with mental math or a calculator, you are welcome to tell me what we get. Again, when we take that 10 times 81, that's where we're going to get 810. And then I would recommend with a calculator, taking 45 times 18. Oh, look at that. That also gives us 810. So down here then, we're going to ask ourselves, did we get the same cross product? Did we get the same number? Does 810 equal 810? Why then, yes. Or in this case, they asked proportional, non-proportional, so I should answer it, yes, it's proportional. Proportional. No, don't put just down the letter P. You can write it out if they ask you that. Spell it out. That's what your math teacher is going to do. So we continue on. Proportional, non-proportional. You have two choices. Do you want to simplify fractions? You might think to yourself, fractions are awesome. You might think fractions are not our friends, whichever you want to do. But if you want to, can you simplify 4/12? Well, yeah, if we took it and divided by 4 on top and on bottom, that gets us 1/3. So right away, boom, yes, done. Now, I know you can do that mentally, but here's the thing. I need to see this work. So even if you're doing that mental math, I need to see this fraction, I need to see that ratio simplified. The other way that always works is the cross product. When we hear cross product, we have to do just what it says. Cross, go diagonal, and product, which means multiply. So when you hear cross product, we're going to do just that. We're going to go diagonal. So everybody, please, even though we already know the answer, please pick up your pencil, put it on the number 1, and draw diagonally, and ricochet off, ping, just like a pinball or ping pong or whatever you want to call it. Please write down the numbers you touched. 1 times 12. Do not tell me what that equals. I know you can do that, but please pick up the pencil, put it on the number 4, and then again, ricochet off, boom, boom. Whatever numbers you touch, please write them down. 4 times 3. Now that we have those written, now please go back and tell me, what is 1 times 12? 12. What is 4 times 3? I said 4, and then I wrote it on the end. Silly Mr. Walls. Here we go. You get 12. Does 12 equal 12? Did we get the same number here? Why then, yes, we did. So answer the question. Sometimes it is it a proportional, yes or no? If they ask, is it proportional? You can write out proportional. iPad's not working very well. Poor handwriting is even poorer. I apologize about that, but moving on. 2/5 and 8/25. Are they proportional? Do 8/25 and 2/5 make a proportion? So again, you can look at it and say, can you simplify both fractions down to the same fraction? Can you simplify both ratios down to something? So taking a look at that, can you simplify 2/5? Nope. Can you simplify 8/25? Nope. So are they the same number? Nope. So then they are not proportional. You can say that right away. However, one more time, I'd like to show you this cross product because we're going to end up using this in a future lesson and also in chapter 6. So please join me on number 2, or rather on the number 2. Put your pencil there and go cross product. Whatever numbers you touch, please write them down. 2 times 25. Don't tell me what it is. I know you can do that with mental math or a calculator, but put an equal sign. Pick up your pencil. Put it back here on the number 8, and then go ricochet off again. Ping, ping. Write down the numbers you touch. Now that you have those written down, now go back and tell me what 2 times 25 is. It's 50. Mental math or calculator. 8 times 5 is 40. So when you look in here, are those the same numbers? Are the cross products equivalent? Nope. So then that's why we're going to say no, or not proportional. Proportional. You got to sound it out. That's all right. So does your math teacher. Again, when we go to the next slide, you can see here why we're looking at this, because right here our big skill is to recognize and represent proportional relationships between any quantities there. So we're going to talk about that and continue on. We can do this in a table, proportional, non-proportional. Again, if you'd like to, you can do cross products. The one downside, though, is if you're going to do cross products, got to make sure you do every one of the cross products. So it's a method, but in this case, I'd like to look right here. I see a fraction. What fraction do you see? I see 1 over 8. Awesome. Ooh, speaking of fractions, there's a fraction. Let's skip that guy. Ooh, there's another fraction. Let's skip that guy. Let's check this guy out. I see the fraction 2/16. Can you simplify down 2/16? Well, yes. Comes out to be 1/8. Now down here then, are we getting the same ratio? Did we get the same fraction? Did we get 1/8 on both of them? Yes. Well, then odds are we do have a proportion, that they form a proportion. However, let's not just presume that. Let's go through here and let's do some extra practice with fractions, or extra practice with complex fractions. I'm going to start here at the very beginning one, this guy right here. I see on top 1/2. So please write down 1/2, put a big fraction line, put a big division line, almost like what you see right here. And put down the number 4. Oh no, a fraction and a fraction. It's called a complex fraction. Pause. It's not that complex. Like we covered in the previous lesson, when you see this big line, that's the key. Let's rewrite it horizontally. Whatever's on top, we're going to take that guy and write it down first. 1/2. Divided by, that's that big line there, 4. Ooh, but we don't divide with fractions. We multiply by the reciprocal. Please remember, 4 as a fraction is 4 over 1, so flip it. You get 1/4. When you do the fraction dance, top times the top and the bottom times the bottom. Would you look at that? Got 1/8 again. 3 times. Boy, we probably could just say yes and move on. And I know you want to do that, but hey, we're in math class, or at least you're watching a math video, so I'm going to do it again, where I want to practice this complex fraction, because it's not that complex. It just means we have to rewrite it, because yes, it looks scary when I write out 3 over 2, and then take this big line, whoosh, whoosh, divided by 12. No, don't panic. Though the name is called a complex fraction, because there's at least 1 or 2 fractions in a fraction, just rewrite it. Notice again, here is that long line. The long line is our dividing. So whatever's on top, write that first. 3 over 2 divided by whatever's on the bottom. 12. Oh, but there we go again. We don't divide by fractions. We don't divide with fractions. So keep, change, flip, KFC. Or again, for us, multiply by the reciprocal. You're welcome to do the fraction dance and tell me it's 3 over 24 and simplify that. However, for me, I'm going to do some cross canceling. The 1 and the 2 does not work. Again, since we're multiplying, we can cross cancel. Between the 3 and the 12, well, 3 goes into 3 ones. 3 goes into 12 4 times. Would you look at that? 1 times 1 is 1. 2 times 4 is 8. We do have the equivalent fraction. So we've got 1/8. Oh, that smiley face is too small. Let's make them bigger. 1/8, 1/8, 1/8, and 1/8. So every one of these then here, this one simplified down to 1/8. This next column and this column, they all simplified down to 1/8. So again, more than one way to get there, but I need to see the work. So since it asks proportional, non-proportional, I'm going to write it on out. It is proportional. Please don't just put down the letter P. Spell it on out. Again, life hack. It's right here in the instructions. So if you need help spelling it out, look right there. It's also in your notes multiple times, so we can do that as well. One last one. When you're in the gym and you're running 3 laps around the gym in 1.5 minutes, you complete 24 laps in 12 minutes. And since you're in gym class, you're wondering to yourself, do these form a proportion? Are they proportional? Well, no, you probably aren't thinking about that. But if you're a long distance runner, which I am not, and I would explain that in class, and if you want to, you can ask me about it. But if you're a long distance runner, it's actually very important to be proportional. You always want to keep your pace consistent, running at the same rate. So let's take a look then. We've talked about it in a previous lesson, so I want to recap it again. When talking about a rate, writing out a unit rate, we talked about something that goes on the top. Oh, do you remember that? Oh, yeah. If money is given, it's usually listed first or written on the top. Otherwise, if there is a time written, then that is where time usually goes on the bottom. So I see a couple of ones here. So let's take a look. Starting off right away, I see 3 laps in 1.5 minutes. Does that have money, which goes on the top? Nope. Does it have a time in it? Aha, it does. So I'm going to put that on the bottom. 1.5 over 3. I have written a rate. I could talk about a rate by putting the labels off to the side if I wanted to. Sometimes we do that so we can keep them straight, where the top stood for laps, the bottom stood for minutes. That's helpful because up next, when we look at our next one, we have got 24 laps in 12 minutes. So I need to write that, but I need to write it exactly right like I wrote the first one. 24 over 12. So again, I invite you to show your work either way. However, you have to show your work. So do you want to just look at and divide these to see if they come out to be the same unit rate? So come out to be the same ratio or fraction? Great. I'm going to, as per usual, show you the cross product again. Bing, bing. Going cross diagonal in the word product. Everybody say product. Everybody say product. I couldn't hear you. Did you say it that time? Maybe you did. If not, remember, product means to multiply. But before you tell me what it is, you must write it out. You must write it out. Show me the work. From there, pick up your pencil. Go to the other one on the top right. Ricochet off. Bing, bing. Write down the numbers. Now that you have those, go back and tell me what is 3 times 12, mental math or calculator. Now you can write down 36. Off to the side, 24 times 1.5, mental math or a calculator. But when we're talking about all of this, I need to see the work. So if you're doing cross product, all of this needs to be written in. If you're doing equivalent ratios, I need to see this to start with, and then that they both simplified down to 2. Can't just say yes or no. Again, using the cross product, though, looking right here, did we get the same cross product? Why, yes. Woohoo! Aren't you so excited? You now know that you ran proportionally, meaning you ran the same rate the entire time. Well, if you don't want to do that next time you're in gym class, at least here in math class, you can put down, yes, it is proportional, or good. Or to ask, is the number of laps proportional to your time? Yes. So that would technically answer the question as well. But it's always nice to spell out that word. Here we go. Again, talking about our standard, focusing here in this lesson on 7RP2, where we're talking about recognizing and using proportional relationships. That's what we're going to talk about. To recognize whether they form a proportion, whether we're using equivalent ratios, or if we're using a cross product, whichever way we want to do that. There are 2 different methods. You need to show the work.